morning, students. Today's topic of our class is process instrumentation diagrams. I think you are familiar with process instrumentation diagram, which has been probably covered under process instrumentation class. But since this is very much relevant for process control, so just a review of this process instrumentation diagram. So far we have covered the different devices and control processes. Just for revision, since we reached at the end of the syllabus almost, only one content is left, and that is the safety measurement system. The basic definition of process control covers that the safety aspect is a major important issue. Okay, that will be covered in next class. For this class, if we just review that in the syllabus, whatever we have covered, for a feedback control system, there is a process, and the measured variable which is to be controlled is measured by the measuring device and then transferred to the controller. The measured signal is transferred to the controller through the transmitter. Then the controller compares the process variable or measured value with the desired value, and if there exists any deviation or error, accordingly the controller will produce the control action, and that will be sent to the final control element. Accordingly, the energy adjustment to the process will be done, that is called the manipulated variable of the process. And the deviation occurs due to change in load variable. That is the basic block diagram of the feedback control system. We have learnt about the process modeling, different parameters for process, then the measuring devices and transmitters, controllers, several type of controllers, control actions, then final control element and its design and characteristics. So and there is another important device, that is annunciator. That is if any deviation occurs in the process variable, then alarm signal will be produced by the annunciator unit. So all these systems are devices and processes are covered. Now process instrumentation diagram means, or the piping and instrumentation diagram, that covers the symbolic presentation of the different units as well as the control loops. These are the different symbols for the pumps, and typically these symbols are used for a pump. This is for centrifugal pump, this is for vacuum pump. So these are the typical symbols. In plant data, for any plant data, just seeing this symbol, you can identify that what type of device is used there in the control loop. This is for tank, this is for drum, this is for open top tank. So all these are standard symbols for different type of pump, compressor, tanks, drums, etc. So these are the definitions: what is pump, what is centrifugal pump, what is gear pump, and different types of pumps and tanks. Compressor. The compressor is a mechanical device that takes in medium and compressed it into smaller vacuum in order to produce the compressed air signal. So what kind of symbol is used for that? These are the process and instrumentation symbols for different valves. This is for gate valve, this is for globe valve. Difference is only there is a dot. This is hand operated and this is auto operated. Needle valve. So these are the different symbols. This is powered valve, motorized. This is float operated valve. So all these symbols signifies the different types of valves. You just have to know that there are so many types of valves are there. And this is solenoid valve. These are the different type of piping lines. Say solid lines, solid bold lines. This is for major pipelines. This is connectors, connecting lines. This is side connections, top bottom connections. So all these are typical symbols. Pneumatic, you are familiar with this signal, that is pneumatic signal. For electrical signal, dotted line is there, and different other type of signals, pipelines. Next is PI symbols for different instruments. This is for indicator, round with the hatched. This is indicator, another type of indicator. What I want to say that this is temperature indicator, TI. First is process variable, and second one is the device. I stands for indicator, T stands for transmitter, R for recorder, C for controller. Similarly, for flow variable, flow indicator, flow transmitter, flow recorder, flow controller. For level, the process variable is L. For pressure, process variable is P, like that. This is level transmitter, level recorder. So these are different types of instruments, and if there exist three variables, PIC, first always stands for, first variable is always stands for process variable, that is pressure. I stands for indicator, C for controller. Sometimes there is another parameter, PICA, that is for alarm. That means the process variable is pressure, indicator, controller, along with alarm signal facility. This is pressure, regulator, recorder and controller. This is level with alarm. So these are the standard symbols. And control loop PI diagram, this is for flow, this is for process variable measurement. This is for flow control loop. The flow is measured. This is orifice symbol. From this symbol we can identify that the control loop is for flow controlling system. This is flow measurement, typical symbol of orifice. So flow is measured, and there must be a measuring device. It may not be shown in the control loop, but there exists. Then it goes to controller. Here it may be FC or FIC, that means if it is along with indication, or FRC if it is along with recorder, then along with alarm signal, that means it is connected with annunciator, then FCA or FRCA or FICA, like that. Then it goes to the final control element in order to adjust the manipulated variable. So this is the diagram, for PI diagram for flow measurement. If the process variable is pressure, then it should be directly connected from here. This stands for if it is directly connected with the flow line, then it is pressure measurement system, and it should be PCA or PRC or PIC, whatever be the controller is, pressure controller or pressure pressure recorder along with controller, like that. If it is a temperature measuring system, then usually temperature measurement system is shown with a thermo-OL symbol. This is for temperature measurement system. So temperature transmitter, you can identify from the process variable written over here. If it is FC, that means the measured variable is flow. If it is PC, that means the measured variable is pressure, like that. So temperature measurement for this is TT, temperature transmitter, and the controller is exists there. So this is a block diagram for distillation column, like heat exchanger system. This is a distillation column. Two different fluids are there. There is a reactor, and this is the gas separator. So low end fluid is separated from the top. The gas is separated, and from the lower portion, the liquid is again sent to another tank for second level separation. From that, benzene is separated, and the lower portion liquid is toluene, and that is again fed to the reactor for conversion. So this is the process of distillation column. This is the typical process flow diagram for a particular plant. We will discuss one example. This is much more complicated. From here we will extract one control loop in order to show the real system. This is another PI diagram for distillation column. This is extracted diagram from one process plant. This is called the deaeration process. Deaeration is required. This is the diagram is actually scanned from the paper, so the diagram quality is poor, but just try to follow that. There is a steam flow line typically of 53 atmospheric air steam pressure. This is generated in one part of the plant, and from that steam of this is 7 atmospheric air. This is 7 ATA steam. ATA stands for atmospheric air. Seven ATA steam should be generated in order to use this into deaeration chamber. This is the deaeration chamber. Deaeration means deoxygenation of water. For boiler drum, the water used must be deoxygenated, so that the if oxygen present in the boiler fed water, then what will happen? Due to high temperature, corrosion may occur within the material. So normally the boiler drum water, this ultimately the deaerated water should be stored in the storage tank, and that should be fed to the boiler drum through the feed pump. This is FP, stands for feed pump. This is steam turbine driven boiler feed pump. So that will send to the boiler drum. So this deaeration process requires the polished water supply from the process plant, and high speed steam is flown from the bottom portion of the tank, so that the oxygen present in the water should be carried out, and this is open to atmosphere. So these are the spraying layers. That means water will fall from the top to bottom through the spraying layers, and the high speed steam will carry out the oxygen present within the water. That is the process of deaeration. So what is this is the total instrumentation diagram of deaeration plant. Now this is the steam supply part, and this is the water supply part. Water, this is the polished water from process plant, is supplied from the top of the deaerated unit, and from where this 7 atom, this is taken from typical process plant, from plant data sheet, and this requires 7 atmospheric air steam flow. But plant from a part of the plant, 53 atm steam is generated. So that steam is used to drop the pressure in order to generate 7 atm steam through certain separator unit. Only one separator, not only one SR4 and SR3, 2 separator units are shown here, but in real system there exists number of separator units. Separator units is nothing but a cylinder in order to release the pressure. So high speed steam will release water, and the outlet pressure is less. Pressure is less compared to the inlet pressure. So only one layer is shown here for generating 7 atm steam. So before sending this separator, there is a heat exchanger. This heat exchanger is basically, this steam line is used to serve the purpose of heat exchanger as a hot fluid, and the process gas for another use, some process gas is utilized, that heat. Then that will be that is entered within this separator unit, where the water is separated and the steam loses the pressure, and the outlet pressure is 7 atm. In real system, there exist several separators in order to generate the desired pressure steam line. And this is the control loop through which this output is measured. See, here is a pressure control loop, PIC 43. This is nothing but 43 is nothing but the tag number. Since this is taken from a typical plant data, so this is the tag is PIC 43. That means the control loop is a pressure control loop along with the indicator facility, and this is the controller along with the controller. This is the control loop, pressure control loop. And if the pressure is less than 7 atm, that will be released to exhaust, and this 7 atm steam line is used here. Just see the path. This 7 atm steam line is used here through this another pressure control loop, PIC for 36, to the lower portion of the drum. So why there exists another pressure control loop? Because this is essential that the steam pressure which will be entered at the lower portion of the deaerator unit must be is of 7 atm steam line. That's why this is there exists another pressure control loop in order to check the pressure. of the flow line. Then so what are the steps? So from this separator unit, the 7 attas steam line is generated, and that steam line is used at the lower portion of the deaerator tank. Now the separated water in the separated chamber SR4 is then used to reutilize. This is nothing but water, so this is used to reutilized through another separator unit. There still some pressure exists within this, so that will be released here, that is open to atmosphere, and the water is then sprayed from the upper edge of the deaerator unit. This is the from source, and this is the recycled water. This is called the reutilization. So water is sprayed from the top of the deaerator tower, and from the bottom of the tower 7 attas steam is sent. So there exists a pressure control loop, and in order to check the level of the controller, level of the separator, that means the drum, there exists a level control loop LICA 17. Again, this 17 does not have any significance, nothing but a tag number. This is level indicator controller along with alarm facility. The level should be checked. See, this is the typical symbol for PIC diagram for level controller. Level always should be measured upper as well as for lower level. So level should be always symbolized as like this, and this is the measuring device. So this is the symbol for level controller. Here no controller or other devices have shown. This is the PI diagram. It may be shown that there exists the controller, or may not be, depending on the space in diagram page, but it stands for, this is the level control system, level controller along with alarm facility and indicator for monitoring. Then after deaeration, the water will be stored in the storage tank. This is LA20. Then that water will be supplied to the boiler drum through the feed pump, and the feed pump is driven by steam turbine. This is steam driven turbine. This is steam inlet and steam outlet path, and again this steam is reutilized in the heat exchanger 1. There exists HE1, so this is another heat exchanger. The steam turbine, the steam supply only drives the turbine. Then after driving, then the steam should be reutilized in the heat exchanger unit. So here the steam will release some water, and this steam and the cooling media, as a cooling media, the water line from the storage tank is used. For heat exchanger there must be a heating media and cooling media. Cooling media is the cold water flow rate from the storage tank. This is suction pump, symbol for C, this is C1, symbol for suction pump, and there exists another level control loop LICA 16. This LICA 16 is for measurement of tank level of HE2. Again, the upper level as well as lower level. For all level measuring system, there exists upper level as well as, because if upper level exceeds, then the water and steam may get mixed, so that the output, again from here the steam line this heat exchanger output is a 7 attas steam line generation. So again this steam line is used and sent through the PIC 36 to the deaerator. So if the upper level exceeds, then the steam quality will be affected by the water, and if lower level if it goes below lower level, then it may dry run may occur. So for level control system, always upper level as well as lower level should be measured. So this is the process scheme for deaeration tower, deaeration process rather. Now there are several control loops like LICS 17, PIC 43, PIC 36, LICS 16, LICF 14. This is for supply water, and the level should be measured and controlled over the level tank, and the pressure steam line supply, that is PIC 33. So all these are either level control or pressure control loops. So you should design the different control loops. That means what type of controller and what type of valves should be used for this control system. Say for LICS 17. For LICS 17, the tank level should be measured and controlled. So what type of valve should be used here? That means we should consider whether this is considering pneumatic valve, is it air failure to open type or air failure to closed type, and what type of controller, means direct action type or reverse action type controller should be connected here. Say for this system, what type of controller should be? First, the valve type. If the valve is air failure to open type, what will happen? Air failure to open type means when air signal fails to reach to the final control element, then that means due to instrumental failure, the valve air failure to open type, that means when signal fails to reach to the final control element, the valve remains open. So it remains open, that means the tank may get empty through this due to during instrumental failure, the tank may get empty. So air failure to closed type may be taken. Again, if we consider air failure to closed type, then what will happen? During air failure, the tank level will rise. During failure, it remains in closed position. That means valve is in closed position, means the tank level may rise and the steam line may get affected. So for both the cases, there exists some problem, but we should consider which one is more important. That means, say for the outgoing, this pressure line should be maintained strictly at 7 attas steam line. We may restrict the output flow to this level also, but if the steam line get affected, that will be transferred to the deaerator. That will in turn affect the ultimate process. So this should be air failure to open type. So this is the method of choice of the final control element. And controller type, mostly controller types are all are PI type. proportional and integral, except if there exists any slow process. That means for temperature system, since here no temperature control loop is there. One second, please. So if there exists any we need to consider the which one is more important process variable, number one, and the controller is mostly PI type, except if there exists any slow process, that is if there exists any temperature control system, then only derivative effect is needed. Otherwise PI control is sufficient for all. In this way, analyze the design aspect of all 6 control loops, considering pneumatic type controller and pneumatic type valves. So that is nowadays all are electronic type controllers. So but valve may be of pneumatic type, so air failure to open or air failure to close type, that should be chosen for operation. So this is the real system instrumentation diagram and process instrumentation scheme for operation. That's all about this is just a application. So that's all about this system, and in last class we will discuss about the safety measurement system using DCS and PLC. Okay, thank you.